Can anybody tell me what kind of a triangle this is? Correct. It's an isosceles triangle. It has two congruent sides. So this section, 4-5, on page 228, is about isosceles and equilateral triangles. Okay, let's dissect a minute a triangle. We've covered this, but let's remember. This point at the top, does anybody remember what that's called? A vertex. These sides are called legs. This side is called the base. These angles are called the base angles. Here's another isosceles triangle. The isosceles triangle theorem states that the base angles right here of an isosceles triangle are congruent. I have the same isosceles triangle with the same congruent base angles, but we have a converse. Converse of the isosceles triangle theorem. Okay, remember, the isosceles triangle theorem said that if I have an isosceles triangle which has two congruent sides, that the opposite base angles are also congruent to each other. What do you think the converse is going to say? This is all I'm given. The two base angles are congruent. I don't know anything about the sides yet. But based on the converse of this isosceles triangle theorem, I can make the statement that if two base angles of a triangle, notice I didn't say isosceles triangle because I don't know yet. If two base angles of a triangle are congruent, then the opposite sides are congruent, and we have and isosceles. I have another theorem. So these were theorems, right? Converse isosceles theorem and isosceles triangle theorem. Now I have a theorem that doesn't have a name. We're just going to call it theorem 4-5 because it's the fifth one in chapter 5. And it has to do with a segment. Okay, so here we have our isosceles triangle, and it has to do with this segment that comes from the vertex and is dropped down. And it bisects this vertex angle. So what actually is it? The bisector, in this case it's a segment. What does bisect mean? Whether it's bisecting an angle or bisecting a segment or bisecting anything. What if I bisect a pie? It breaks it into two congruent pieces. So the bisector of the vertex angle of an isosceles triangle is also the bisector of the base. Okay, so in shorthand, okay, so this also creates a 90-degree angle, meaning it's perpendicular. So what does this all mean? Okay, we have the isosceles triangle, and we have the bisector. So first of all, it bisects this angle on the top. So what does that mean about these two angles? It means they are congruent to each other. So here I can draw two arcs, so I know this is congruent to this. And the other thing is, what did it do down here? It bisected the base. So that means that this is now congruent to this. Okay, I have two more things, and then we'll get on to our worksheets. And they are called corollaries. A corollary is a statement that follows from a theorem. I have two. I have corollary 4-3, which says that equilateral triangles are also, and we know this, we've talked about this, are also equiangular. And corollary 4-4 is the converse. What do you think it's going to say? It's going to say that equiangular triangles are equilateral triangles.